Hello everyone. For this session we will discuss hyperbolic functions. Hyperbolic functions is the one of the kind of trigonometric functions. For trigonometric functions we have to use unit circle. So here we can consider the coordinate axis. This is the coordinate axis. You know that coordinate axis means the both x and y axis are called coordinate axis, and also the point of intersection of the axis is origin. Here we can consider any unit circle. Okay, so here this is the unit circle. You know that unit circle means if any circle having the radius is 1. So clearly this is point some 1, 0. So let us consider any point P on the circle. For example, this is the point P some x, y, and join OP and draw a perpendicular line from P to x-axis, meet at the point some M. Now clearly we know that horizontal distance, that is OM, which is equals to x coordinate of P, and PM. PM means what? Vertical distance, that is y coordinate of P. Okay, and the angle between OM and OP is some angle theta. Now we know that the unit circle equation is x square plus y square is equals to 1. Okay, now here sin theta defined as opposite side by hypotenuse. So clearly what is the opposite side? PM. PM is what? Y. Divided by hypotenuse, that is OP. Clearly this is the radius 1 unit. So y is equals to sin theta. Similarly from the triangle OPM, cos theta defined as adjacent side, that is OM. OM is what? X by hypotenuse 1. Clearly x is equals to what? Cos theta. So here the point x, y, that is equals to what? Cos theta, sin theta. So clearly this point satisfying the unit circle equation, means which is the parametric points. So here substitute here cos square theta plus sin square theta 1. So that's why for trigonometric functions we have to use unit circle. But in hyperbolic functions, for hyperbolic functions we have to use hyperbola. So again we have to consider the coordinate axis. This is the coordinate axis. This is x-axis and this is y-axis. Okay, here we can consider any hyperbola. So this is the hyperbola. Here hyperbola crosses the x-axis to some 1, 0. Here negative x-axis, that is minus 1, 0. Okay. Now consider any point P on the hyperbola, that is some x, y. We know that the hyperbola equation is x square minus y square is equals to 1. Here we can consider any parametric point that satisfying the hyperbola equation. So that is x is equals to some e power x plus e power minus x by 2, and y is equals to e power x minus e power minus x by 2. Substitute this point in the hyperbola equation, that is e power x plus e power minus x by 2 whole square minus e power x minus e power minus x by 2 whole square. So here we can simplify this. What is the LCM? LCM is 4. So here which in the form of a plus b whole square minus a minus b whole square. So clearly we know that formula is 4ab. 4 into a is e power x and b is e power minus x. So clearly e power x, e power minus x reciprocal, and 4 get cancel, which is equals to 1. So means the point e power x plus e power minus x by 2, e power x minus e power minus x by 2, satisfying the hyperbola equation. So clearly x is equals to e power x plus e power minus x by 2, and point y is equals to e power x minus e power minus x by 2. So clearly e power x plus e power minus x by 2 are defined as cos hx, and e power x minus e power minus x will be defined as sin hx. Okay, so here the both cos hx and sin hx means the point x comma y equals to what? Cos hx comma sin hx, which satisfying the hyperbola equation, that is x square minus y square equals to 1. So that's why for hyperbolic functions we have to use cos hx and sin hx. Once you go through all these formulas, for next session we will discuss few problems on these formulas.